I'm Dr. Dhananjay Kumar Tripathi, an assistant professor of physics under the Department of Basic Science and Humanities. So in the last class, we have discussed the CRTs. Today we'll discuss some more advanced display devices like LCD, liquid crystal display, and LED display, light emitting diode display. So let us discuss one by one. At first, we will start with the LCD. So all of you are using LCDs in your mobile, in computer, in laptop, in TV screens. So what are the common features of LCDs? Let us discuss that. LCDs are light in weight, they are compact, and they occupy less space, they consume low power, and they are found in reasonable price. There are two types of LCD technologies: active matrix LCD technology or thin film transistor technology. Second one is passive matrix technology. The TFT technology is more reliable with better image quality, while the passive matrix technology has a slower response and gradually becoming outdated. So as the name indicates, liquid crystals are key elements of the display screen. There is a display controller in the monitor which receives the display signal from the video adapter in the motherboard. The display controller controls two things: the electric signal to the liquid crystal and the backlight. To make a LCD, we need to take two polarized glass pieces. The glass which does not have a polarized film on it must be rubbed with a special polymer which creates the microscopic grooves in the surface. This is a LCD display. This is a computer screen which is using the LCD display. Now, we need to do to add a coating nematic liquid crystal to one of the filters. The groups will cause the first layer of molecules to align with the filter's orientation. At right angle to the first piece, we must then add a second piece of glass. I have written it for your suitability with the polarizing film. Till the uppermost layer is at 90-degree angle to the bottom, each successive layer of TN molecules will keep on twisting. The first filter will naturally be polarized as light strikes it at the beginning. Thus, the light passes through each layer and is guided onto the next with the help of molecules. When the light reaches the far side of the liquid crystal substance, it vibrates at the same angle as the final layer of molecules. It is very important thing. Just we will see that. The main principle behind liquid crystal molecule is that when an electric current is applied to them, they tend to untwist. That means when electric current is applied to the liquid crystal, they tend to untwist. This is very important thing. And because of that, the light angle will change. And when light angle will change, then the top polarizing filter with respect to it will also change. So little light is allowed to pass through that particular area of LCD, and that area becomes darker comparing to the others. Now you see in the bottom mirror is used, and this is liquid crystal layer which is put in between the negative electrode and the positive electrode. This positive electrode and negative electrode are having the rectangular shape, and two polarizing films at 90-degree to each other are put. I discussed just now. Now there is a cover glass on which the image will be displayed. For making an LCD screen, the reflective mirror has to set up in the back. That we did. An electrode panel. Oh, one more thing is that the common electrode will be running throughout the LCD. An electrode panel made of indium tin oxide is kept on the top, and glass with a polarizing film is also added on the bottom. And very important thing is that the two polarizing films must have 90-degree angle. So what happens that the entire area of the LCD has to be covered by a common electrode, and above it should be the liquid crystal substance. Another piece of glass with an electrode in the shape of the rectangular on the bottom, and on top another polarizing film. It must be noted that both of them are kept at right angles. Both of them. When there is no current, this is very important thing. When there is no current, the light passes through the front of the LCD. It will reflect reflected by the mirror. The mirror will reflect the light. And when the light will be reflected back by the mirror and bounced back, as the electrode is connected to the temporary battery, this electrode is connected to the temporary battery, the current from it will cause the liquid crystal between the common plane. You see, this liquid crystal is in between the negative electrode and the positive electrode. So common plane electrode and the electrode shaped like the rectangular to untwist. So this will untwist, and because of this untwisting, the light is blocked from the passing through. Thus, that particular rectangular area appears blank. An active matrix liquid crystal display, AMLCD. AMLCD is a type of flat panel display. Currently, the overwhelming choice of notebook computer manufacturers due to the lightweight, very good image quality and wide color gamut and response time. This AMLCD is used for the making the notebook computer manufacturers are using there because of its light color and very good image quality. The most common example of an active matrix display contains, besides the polarizing sheet and cells of liquid crystal, a matrix of thin film transistor TFT to make a TFT LCD. At the beginning, when LCDs were used in calculators, watches, and small size displays, direct and passive matrix addressing were the applicable addressing methods. But with increase in the pixels, the number of pixels array was also increasing. Because of that, the existing addressing methods to become non-applicable. This becomes non-applicable. How to address these many pixels? So a solution was given in terms of TFT, thin film transistor technology, which was added at each pixel of the display matrix, and in this way the pixels were controlled independently with the use of external driving voltage. So external driving voltage were used by these TFTs. So because of that, the power consumption becomes less. So the use of TFT is to reduce the power consumption in LCDs. Display devices in TFT monitor is a flat array of thin film transistors, which makes the TFT monitor much smaller in size and also less power consuming. Now, what is thin film transistor? These are the special kind of field effect transistors, and these are made by depositing thin films of active semiconductor layers. As well as dielectric materials can also be used to form them. Now, a common substrate is glass because the primary application of TFTs is liquid crystal displays. TFT depends on the silicon's crystalline state. The semiconductor layer can be either amorphous silicon, microcrystalline silicon, or it can be annealed into polysilicon. So it depends on the manufacturer that what he is taking. Applications. TFT technology can be used to give one of the clearest picture of any flat screen display, and it uses much less electricity than older screens. It is very important thing that very less amount of power is required. TFT displays are very fragile because they are made as thin and light as possible, but this means that they need far less space. They can be used in extremely wide range of our everyday life products like mobile phones, applications, mobile phones, ATMs, PDAs, navigation systems, notebooks, PCs, home applications, widescreen TVs, everywhere they can be used and they are used. Advantages of LCD. Image is perfectly sharp in LCDs at the native resolution of the plane. Zero geometric distortion at the native resolution of the panel is seen in LCD. LCDs have high peak intensity, so they produces the high peak intensity. Because of that, the images are bright, best for brightly light environment. For bright light environment, this is used. Screens are perfectly flat, thin with a small footprint. So these screens are very thin, and footprint is very small, so they require very less space, consume little electricity and produce little heat. So heat is also produced in less amount. Because of that, you can work for a longer time. Now, disadvantages of LCD. This LCD is having many disadvantages. We'll quote some of them. Each panel has a fixed pixel resolution format determined at the time of manufacturing, and because of that, they cannot be changed. So if an image resolution requires rescaling, which generally results in significant image degradation, so that cannot be done. Degradation will be there. If you want to change the resolution, we cannot do that as per rescaling. Rescaling cannot be done in the case of LCDs. LCDs using an analog input require careful adjustment of pixel tracking or phase, or eliminate digital noise in the image. If we want to eliminate the digital noise, then we will have to do that. Otherwise, there will be digital noise. Limited viewing angle. And we know that brightness, contrast, gamma, and color mixtures vary with viewing angle. So if viewing angle is limited, we cannot change all of these qualities to a large extent. Black level contrast and color saturation is also limited in the case of LCDs. LCDs have difficulty producing black and very dark rays. As a result, they generally have lower contrast than CRTs. Color saturation is not good there. They are not suitable for dim light. And for the dark environment, they are not suitable. The bright end of the LCD intensity scale is easily overloaded, which leads to the saturation and compression. LCDs can have many weak or stuck pixels, which are permanently on or off. Some pixels may be improperly connected to adjoining pixels, rows or columns, as the panel may not be uniformly illuminated by the backlight, resulting in uneven intensity, and because of that, shading will be seen on the screen. So this is very bad thing about the LCDs. Slow response times and scan rate conversion result in the severe motion artifact. Due to that, the image got degraded. LCDs have fixed resolution and aspect ratio. For a panel with resolution 1280 by 1024, the aspect ratio is 5:4. That is 1.25. This is very small. And they are more expensive than CRTs. LED displays. Now, what is LED? LED, the full form of LED is light emitting diode. We have learned that what are LEDs? LEDs are forward biased PN junctions in which the energy released due to the recombination of electron and hole is in the multiple of h nu, that is one photon energy. Actually, what happens that if there is conduction band and there is valence band, so in the conduction band there are electrons and in the valence band there are holes. So when these electrons falls to the holes, and if this energy is in integral or integral multiple of h nu, then we will have the visual sensation, and this particular PN junction, forward bias PN junction, will be called as LED. So LED display refers to the light emitting elements, which is the composed of the LEDs. LED, the light emitting diode array, is directly used as pixel to emit red, green, and blue light. You just recall in first year we have discussed that, and you have seen in the lab also that there are different colors of LEDs are available. You have experimented with them. So if different colors of LEDs are arranged, then they can give the display of different colors. Now, one thing is very important about them, that when electrically biased, when a semiconductor diode that emits incoherent narrow spectrum of light when electrically biased in the forward direction of the PN junction, this, if this gives the energy in the form of light, then this is called as electroluminescence. Now, this is a picture of LED display. LED is usually a small area source. The color of the emitted light depends on the composition and condition of the semiconducting material used and can be infrared, visible, or near ultraviolet. LED, uh, LED can be used as a regular household light source. In silicon or germanium diodes, the electrons and holes recombine by a non-radiative transition, which produces no optical emission. So no display will be seen because their band gap is indirect. But if we take the material whose band gap is direct, then we will see the infrared, visible, or near ultraviolet light sensation. LEDs are usually built on a N-type substrate. We know that. With an electrode attached to the p-type layer deposited on its surface. So LED consists of a chip of semiconducting material impregnated or doped with impurities. Doping is what? The adding of impurities to pure semiconductor or intrinsic semiconductor. When this PN junction diode is forward biased, carriers are injected across the junction to establish excess carriers above their thermal equilibrium values. These excess carriers recombine and release electromagnetic energy. The wavelength of the light emitted and therefore its color depends on the band gap energy of the material forming the PN junction. In the case of gallium arsenide, the energy appears in the form of infrared radiation. For the alloys semiconductor gallium arsenide phosphorus, the energy appears in the form of visible light. The PN junction diode constructed with such semiconductor, that is gallium arsenide phosphorus, is called conductors is called the light emitting diode, because we used to get the optical energy, that is light energy, during their forward biasing. I described that how the electrons will recombine with the holes to give the light energy. If the light energy is in band gap is such that this Eg is band gap is such that this is equal to h nu, this is one photon energy, or Sc by lambda, then the wavelength will be Sc by Eg. That means at that time we will see the light in the visible range. Diodes built with gallium arsenide phosphorus are most commercially available because of lower cost and easy fabrication. These LEDs are used for in the manufacture of signals and displays. The infrared LED is potential source for optical fiber communication. The LED displays should be precisely called as LED backlit LCD monitor. Advantages of LED screen. Now these LED screens are very much attractive because of their slim screen and sleek design. So people are always attracted towards it. This is better than LCD monitors because they do not use fluorescent bulbs. In the case of LCDs, we are using the fluorescent bulbs. So because of that, it becomes bulky. So weight becomes more than this LED, and also they are releasing the heat energy. So because of that, there may be some problem with short circuiting, or you cannot work for a longer time. Whereas with LED, in the LED, fluorescent bulb is not used. So you can work for hour and hour. This LED screens consumes less energy and save a lot of power. Provides bright image quality by enhancing the contrast and enriching the range of colors. Range of colors are also large. The images in LED screen is flicker free. Due to that, there is no fatigueness in our eyes, there is no eye strains, and headaches are not occurring due to use of LED screen for hours and hours. These are environment friendly and these are also easy to use. These are very efficient in giving response, and also by controlling their brightness and color, we can control the eye fatigueness. They do not produce heat. I told you and because of that they do not contain the fluorescent bulbs. As they do not contain the fluorescent bulb, that is why they are not producing the heat, and this is also the cause of non occurring of short circuiting. So LEDs are very much, we can say that, useful for us, and they are, this is the recent technology. In the recent technology, we are using the LED screens in computers, in mobile phones, costly mobile phones, in TVs. But there are some disadvantages also with the LEDs. These are very expensive. LEDs are very expensive because of their very high cost. Another thing is that there is a knowledge gap between the user and the manufacturer. And because of that, people do not know how to work with or how to use with the LEDs. And in the LEDs, correct engineering is required. If the engineering is not correct, if there is some defect, then it will deteriorate. The color is also shifted with age. So as the LED becomes older, the color got shifted. White LEDs are inconsistent because thermal stability is not there. Temperature is not constant there. Due to that, the white LEDs are inconsistent. So this is a common fault in the LEDs. Now, many research is to be done for our LEDs. Now, these are the references which you must go through to understand LCD and LED in detail. As you are the student of computer science, so certainly you will require the knowledge of all of them. I have described the physics behind them. Many things are to be known. So just follow all these references for better understanding, and thank you.